Thank you everyone for joining me for the very last session of NDC Sydney. Have you all had a good week? Yep, and you're all exhausted, so I got one tired yep, and the rest were lazily nodded heads. I will just point out one more thing. There is an event after this. It's not related to NDC Sydney. It's not official, called PubConf. If you wanted to come along, pubconf.io, and there might be a ticket or two left, and I literally mean like 1 or 2 tickets left. So give it a look if you're interested in that. All right, so my name is Damian Brady. I work for Microsoft. I work out of Australia, essentially work from home as a cloud developer advocate, which basically means my job is to advocate both for Microsoft, for our cloud, Azure, but also to advocate for the community. And one of the reasons that I'm interested in this kind of idea of the process of data science is because, being perfectly honest, I don't think right now we do a good job of this. And in fact, I don't think anybody does a great job of this, right? My expertise is in DevOps, but I've started getting interested in things like machine learning and data science and so on as well. And this is something that I've been focusing on a lot. Now, right up front, I'm going to give you a little bit of a warning. This talk is like maximum buzzword. There's DevOps in it, there's machine learning, there's like data science. If I had blockchain in it, heads would explode, all right? I'm not going to talk about blockchain, but I am going to say, I'm going to try and step away from the buzzwordy stuff and talk a little bit more about practical ways that I think the stuff that I do with DevOps and we talk about with DevOps can help when it comes to a data science process. I'm sorry, I'm going to get off that slide. It's giving me a headache. Just so I know who's in here, can I just ask, who would consider themselves more of a developer or operations person, so along that side of this two-part system? Okay, that's most people. That's good. Anybody who would consider themselves first and foremost a data scientist? Okay, nice. All right, so it's mainly developers, which you'd probably expect at a developer conference. And that's kind of where I come from as well. I've been a developer for nearly 20 years, or professional developer for nearly 20 years, but I wrote my first line of code when I was 10, so I've been doing that for a little while. Data science, though, is really pretty new to me. And I remember looking at it when I was at university. I saw some projects that were really interesting and really cool, and I asked what it would take to write the neural network that somebody had written, and he started talking about deep, dense trees and like forests, and asked me how my multi-dimensional calculus was, and so I backed well away from that because I was not good at that stuff. I did one subject at university that had calculus in it, and I did it by accident because the person who was telling me what subjects I needed to do gave me the wrong subject code. I got a 3 in that, which was technically a pass, so I didn't have to do it again. So this idea of these two different fields, like I do a lot of stuff with DevOps, but then there's this data science part as well. These are really quite often two different worlds. So what I'm trying to focus on is how there's a bit of overlap between the two fields, and what does that overlap look like? Like, how can these two fields influence each other? And especially coming from a DevOps perspective, how can we use some of those techniques to build in the process or to assist the process when it comes to data science? Because more and more, the outcomes of data science, predictive models and things like that are being embedded in our applications. Like, if you wanted some way of doing handwriting recognition or like predicting whether somebody is going to default on a loan that you've just given them, if you wanted that in your software 20, 30 years ago, it would have been really difficult to do. You would have needed your own department of data scientists to work that stuff out, and it would be a difficult thing. Now, it's a service on Azure. Like, you throw it some data and get a predictive model out the other end, and if you're happy with it, you include it in your application. So we've kind of got to this stage of commoditization of artificial intelligence and machine learning, but putting that into the developer process is something that's just not really happening at the moment. So I want to look at what this area is. Now, as I said, I feel like I know my stuff when it comes to DevOps. I'm in this team of League of Extraordinary Cloud DevOps Advocates that we nicknamed ourselves. It just rolls off the tongue. I'm on podcasts every now and then talking about DevOps. I have a Channel 9 show on Microsoft called the DevOps Lab. So I kind of feel like I know my stuff with DevOps. But then when it comes to the data science stuff, Not so much. So if you put me on a scale of stuff that I know with data science, I'm kind of below the nah, yeah stage of that. But thankfully, working for Microsoft, you get the opportunity to speak to like a ton of people who do know about data science. So that's just a handful of people I've spoken to in the last few months about this topic specifically. So I can leverage some of their knowledge as well, and that's really, really helped. So what does this overlap look like, right? What are we actually trying to achieve? And let's start on the left here. Let's start with DevOps. What does DevOps actually mean? So this is our definition of DevOps at Microsoft, the union of people, process, products, and, to enable continuous delivery of value to our end users. The idea really being that you're focusing on the value that you're delivering to people, and you're focusing not just on the product itself that you use to do all of this stuff, like your source control and your Azure DevOps or your whatever tools you use. You're focusing on the process and being able to push this value out into production and work out whether it is valuable or not. Kind of the idea is to do this fast and sustainably so that you can push smaller pieces out to production quicker and get feedback on those really, really fast. So this is kind of what it's about. There's a really, really good report that comes out every year called the State of DevOps Report. I would highly, highly recommend you have a look at it. The basic summary of the State of DevOps Report, and there'll be a link in a slide in a second as well if you're taking a photo, just out of interest. The crux of it is there's four kinds of metrics that you want to focus on when it comes to DevOps. There's deployment frequency, time to restore service, lead time for changes, and change failure rate. And the summary of the summary is really that teams that do this stuff well do it way better than teams who don't do it well. And in fact, the gap between the people who are doing it well and the teams that are not doing it well is widening, which is a bit of an issue. So as an example, people who do DevOps well can deploy their stuff 46 times faster than people who do it badly, right? Time to restore service. If something goes down, elite performers, as classified by the cluster analysis in this report, elite performers are 2,500 times faster at restoring service when something goes wrong. Now, that seems like a ludicrous number, right? But if you think about the teams that do this the worst, when something goes down, there is so much process in the way of fixing that problem that it might take them a few seconds to break the thing, but it's going to take them 6 months to get everything back up and running. So these are legitimate numbers, and there is a lot of academic research in this report. This is not just somebody doing a whole bunch of SurveyMonkey things and then saying, hey, here's what it is. There's 30,000 data points. It's published in journal articles. There's really, really rigorous analysis behind this stuff. So you can take this stuff to the bank. That is the link there. They just created one, just a bit.ly short link, 2018 DevOps report. But if you search for the State of DevOps report, it's really, really, yeah, it's accessible. It's around all the time at the moment. I could talk about that report itself for a 4-day workshop. There's so much great information in that, and it doesn't matter what industry you're in, this stuff holds when it comes to actually delivering value to production. So that's kind of why you want to do it is proven in these reports, and it means getting stuff out faster and focusing what's on in production. Let's kind of just simplify the process that you go through in DevOps, and this is my super simple cycle of a DevOps process. You do your planning and your tracking, so what work are we doing and how is that work going? You develop that code or you make those changes, you test it, you make sure that's all right. You create builds and test those builds and make sure they're all right, and then you deploy it out to production, and then you watch what's happening in production. Not just, am I getting exceptions, but are people using this feature the way that I expected them to, or do people hate this feature and we shouldn't do any more work on it? And then you put that information back into your planning and tracking, and you iterate as fast as you can around this cycle while maintaining stability. One of the other things that came out of that Accelerate report was that these things move in tandem. So stability and speed actually move in tandem in organizations that do things well, which is counterintuitive sometimes, especially in organizations where they're like, well, no, we need months and months to test this thing so nothing goes wrong. In organizations that deploy really, really frequently, the quality actually just goes up because each time they deploy something, the blast radius is smaller. So this is kind of the idea. You put processes in place so that you can cycle through this really, really quickly, work out what stuff is useful and what stuff isn't, and iterate really quickly, pivot on the stuff that's useful. So that's kind of how the DevOps stuff works. And we're talking about software development here, right? Working out what you're going to put in production, putting it there and monitoring it. Data science, again, not my core field. This was the best definition that I found, or the one that resonated the most with me. And there's a lot of words on the screen, so I'm just going to have a drink and let you read them. And then I'll highlight my highlights of the thing. So the general summary of this is that it's a super broad field, right? Projects in data science can be anything from, hey, we've got a SQL database here. Can you just have a look and tell me what the average amount of money we're spending on this thing is, as like a once-off? That could technically be a data science project. Let's go project. Or it could be building a really deep neural network using streaming data from something to do real-time predictions of what people need to do next in a finance application or something like that. You know, these things are very, very different projects, but they still come under data science. And it's not just the process. There's theories of data science. There's different models. There's convolutional neural networks. There's all the different parts of these networks, and all of that kind of stuff is all part of this big field of data science. The end goal of this, though, is to be able to extract knowledge from data so that you can make better decisions from a business point of view. So that first example of how much are we spending on this particular item, there's a reason that somebody wants to know that, right? They want to know how much we spend on this particular thing in our business so that we can plan for the future. The neural network that you build that does predictive analysis of whether somebody is going to break their loan or stop buying your service or something based on this really, really deep, complex network, the answer to that is going to drive business behavior. It is, what do we do if we think somebody is going to cancel our service? Or what do we do if we think somebody is going to default on their loan? That's really what it is. You have data, you squish that data into something and you get an answer out the other end, or a model that's going to give you a prediction out the other end. That's my take on it, right? On what data science is. And again, to totally simplify the process, this is what usually happens. There is a phase of acquisition of data and understanding of what is required and understanding that data. There's a preparation phase of the data to say, this is what the data looks like, but we need to change it so it looks like, this, it's in this form so we can operate on it. So for example, you might have free text fields that somebody's put in a database somewhere and you want to extract the most, commonly used words, or that's one way that you might prepare it. And then based on that, you can create a model that describes that data and can help you make predictions. You might look at that model and say, well, that's actually not describing the data. It's not helping me at all. And so you go around this loop of acquiring data, understanding the data, preparing it, and then creating these models. At some point, you deploy this model out to production. And that literally, deploying to production could be printing a report and putting it on your manager's desk, and then it's in production, right? Or it could be deploy it in a Docker container to a production system so that your web application can call that service. There's a lot of different variation on that as well. Quite often, though, that last little arrow going from deploy and evaluate back to acquisition and understanding, sometimes that doesn't exist, that arrow. So this is a cycle, and this is what we're familiar with in computer science. It's not necessarily the way that data science works. That might just be a once-off project, or that arrow only occurs once a year. They only want that number once a year. So there's a difference there as well. There's a lot of focus in DevOps for data science around the actual deployment. So containerizing your model, or putting it in a portable format and then importing it into an application. So operationalizing it. But I think there's a lot of value to be added by DevOps in this cycle here. Doing the work that actually produces the models and iterating around that, so you're not repeating work so much. Now, I mentioned before that there's not as many formal processes. We have tons of formal processes for software development, and we've been through various iterations of waterfall and agile and XP and Scrum and all that kind of stuff as well. There's a lot of formal stuff that we do in computer science, but not. I said there's not so much in data science, and it's not actually true. When I went to verify this, I found a whole bunch of formal data science processes. So knowledge discovery in databases, or KDD is one. Crisp DM's one. The cookie cutter data science template is one. And then there's one from Microsoft, which was pointed to me by Lace, right? When I spoke to you about it. She was one of the icons on the graph of how much people know. So the team science data process is a thing that Microsoft develops about how we do data science projects, right? And it's a template and a series of rules and things like that. It basically splits your data science process into a series of phases, which is really similar to what I was talking about before in that cycle. There's a business understanding, so what exactly do we need to do? What are we trying to solve here? Data acquisition and understanding the data, creating models, deploying them, and then the customer acceptance stuff of we've completed this project, it's good to go. Now for me, this is a little bit waterfall-y. It's a bit more, it seems to me a bit more like, okay, here's the requirements document, here's a specification, here's your code, deploy it to production, and everybody signs off and everything's all right. But I'm coming from a computer science perspective, right? So I look at this and I think that seems like waterfall, right? If you look at the detail, it's not quite like that. I mean, there's actually a lot of detail in this document, and I'll put a link up to that document soon as well. Actually, I think I put it up at the end. So there is a lot of stuff in there. There's templates, there's tooling, there's some awesome stuff in that team science data process. I would strongly recommend you go and have a look at that too. So there are these life cycles for these two different fields. Computer science, or the stuff that we do with DevOps, and data science. And this middle bit is kind of what we want to see. But we noticed there's a bit of difference between what we do with computer science. It's very iterative and like you go through deploying tiny little increments of bits of code and you build up this application, whereas a data science project might have a single model at the other end, and you do it once and you don't do it again for another year. So is there kind of an overlap between these at all, or are these two totally different fields? And that's not, it's not actually universally accepted that there is an overlap. There was a really interesting tweet where somebody tweeted about a session that they went to with Jeremy Howard, who I don't really know, but this tweet was very interesting. Just saying data science code doesn't need to follow rules of good software engineering because it's not about creating software. It's about experimenting and building prototypes of models, right? So in other words, hey, it's an experimental thing. You look at data and then you create a model at the other end, and it doesn't need to follow good software development practices. It's a totally different field. Now, in fairness, that was kind of a misquote. And so Jeremy Howard actually came back and said, look, to clarify, you still have to follow rules, and they're different, but they're pretty overlapping, or they're partly overlapping with software engineering. So in other words, if you're a software developer, try to learn from data science and vice versa as well. So it's not completely clear that there is this really clear overlap, but coming from a DevOps perspective and looking at what these data science projects do, I really feel like there's a lot of stuff in DevOps that can be applied to data science really nicely. All right, so there's a few things I think you need to care about as a developer trying to tell data scientists how to do their job, right? And I think the animations have gone weird here, but there is languages and tools. So the languages and tools that we use as developers are going to be different to the tools and the languages that data scientists use. I spoke to somebody a while ago about how we at Microsoft recommend people do their neural network trainings and things like that. And they said, well, you just write your Python in Visual Studio. I'm like, nope, you're not going to do that. If somebody told you, like let's say you write C#, if somebody said, oh no, we're actually going to write C# now in Eclipse or something, just go do that, you're not going to be as productive, right? Because that's not the tool you use. So we don't want to replace the tools that data scientists use, and we don't want to get them to start writing C# if they've written Python or R for their whole careers, all right? So maintaining the languages and tools and building on top of those. There is a lot of experimentation that goes on in data science, all right? So you might have a theory about how this data fits together and how a model might be created. You might think it's going to be explained by this particular model function, and you just need to do some training with a neural network that looks like this and all that sort of stuff. So you run experiments, and maybe they succeed and maybe they don't. It's very much a science, but it's experimentation based, right? So you really need to take into account the fact that there are experiments that you need to run, right? As a matter of course in data science. You can almost think of it like extreme spiking. Like if you're a developer and you do spiking where you're like, I'm using a new component, let me just try this for a bit and see if it works. Okay, that's probably going to end up solving the problem that I want it to solve. Let's put it back in the real application, right? It's that a little bit more extreme, right? It might happen all the time. So experiments are definitely something that you need to take care of. The other aspect with this as well is it's really important that you keep track of those experiments. So very much the same as you have source control, so other people can look back and see what you did, or documentation, so other people can look back and see what you did. It's really useful for a new data scientist coming in to be able to look at a previous experiment and say, oh, okay, they tried that and it didn't produce the result they wanted. So that's really important as well. The other thing is, and I mentioned this, is the life cycles are very different. We really push in DevOps terms now that you treat your project a bit more like a product where you do small iterations and you cycle really, really quickly. You may not be doing that in a data science project. You may be doing it once and never doing it again. So you need to be cognizant of that. Building an entire full pipeline to do everything in a deployment when you're doing a once-off query to generate a Word document, you don't need to do it, right? So in some cases, you don't need to do everything. And then finally, you need to work out whether there's some kind of traceability or explainability. And this can sometimes be hard in, especially in machine learning stuff. Sometimes your project requires that you need to be able to explain how you came up with the model that you have, especially if you're operating in Europe, for example. If you used a ton of customer data to come up with a predictive model, you need to be able to explain what data you used and how your model came up with the predictions that it came up with, right? That means that you need to be able to trace exactly what you did to get this model out the other end. So even though the process, or even though data science projects are a bit different, it's still not acceptable in most cases for a data scientist to do some work on their machine and then say, oh, here you go, here's a predictive model, here's a pickle file that I gave you. Like, you need to be able to trace what they did. You need to be able to find out what happened to get to that point, right? It's a little bit like the developer sitting in the basement of a old school company, and the code only exists on his hard drive or her hard drive, and they write all their code and they pull out the DLL at the end of it and then go, there you go, right? You can't do that anymore. So similar kind of thing. One thing as well when we talk about DevOps for data science is people quite often focus on the operationalization. They say, oh, DevOps, yeah, that's where you take the output and you put it in a Docker container, right? We can do that. We can help with that process. I think there's a lot more that you can do here. So I'm going to run through a number of practices that are really common in software development and in DevOps that I think can be applied very largely to data science projects. And I don't want to be prescriptive about, so here is exactly what you should do, right? These are things that I want you to think about that you can take from DevOps and bring into data science projects. So the first thing is source control, right? It is just, if you run into a company now that is not using source control, that is a real anomaly at the moment. However, there's a lot of data science projects where the source code is somebody's bunch of queries in a folder in their documents. Like, it's not always common for somebody to have all this stuff in source control. And it is really important whether it's Git and you're forcing the data scientist to use Git, or whether it's just the tools that they use having some kind of history of what they've done. History of experiments they've run, history of the code they've got, the changes they've made, and some way of actually having a canonical piece of information saying this is what we did at a particular time, right? If your data scientists are not developers, and that is most of the time, then they're not going to understand when you say, no, we need you to put everything in a Git repo, right? The fact that you need to keep a history, though, shouldn't take away from that, right? So think about having histories of what you've done and the code that you use to produce these predictive models. Sometimes as well, when we're doing this work, so the ETL phase or the data acquisition and transformation and all that kind of stuff, that stuff gets shipped aside. So somebody will say, oh, there's my real data set, but to do some training, I need to tweak it this way. I'm going to tweak a bunch of it. I'm going to take an extract of it, and I'm going to create this new database. Oh, I'll change this field. I'll change those ones. I'll remove these extra records that are outliers. Okay, oh, here's the data that I'm using now. But that process of getting from the canonical data to the data that you're going to use to create your model, that whole process needs to be codified. It needs to be in some kind of system that acknowledges that this is what you have done. So source control is a great way of doing that, but don't force your data scientist to use Git or something like that. Try and get the tooling that does that work for you. Something that we do in software development a lot is refactoring. So this actually helps with DevOps a lot. If you can make a change to your code such that it's easier for you to make subsequent changes, then it means you can move faster, right? If you can change the way that your data is stored such that it makes it easier to query things later on, that's maybe a worthwhile endeavor, right? So if your data is just stored in like as a series of documents just sitting in a folder somewhere on a data server in your environment, maybe the application that's writing those logs or writing that data could publish to some kind of event stream. And then you could store that data in a different database that contains everything, but in a format that is going to be useful for you later on. So refactoring the way that you are storing your data can be really valuable. There's projects as well where you need to make sure that you can revisit what the state of the data was at a particular time. So if you have data that can change, that you can update, maybe that's not actually appropriate for your data science project. You might end up with a predictive model, and when they say, how did you get this model? You don't really know because the data doesn't exist anymore. It's been changed since then, right? So refactoring to maybe change the way your data is stored can be really handy as well. Another thing that you can get from DevOps, the DevOps process, is we talk about infrastructure as code. So not only are we storing the code that does the work, but we're also storing code that defines the environments that that code runs on. Now, in data science terms, you might need to do your training on a particular machine or a particular configuration with certain versions of your Python dependencies and things like that. If you can codify this, it means that the developer who is doing the training while they're experimenting with things, while they're exploring the data, they are using the same system that you can use to train on your petabytes of data later on to produce that model file. It means when a new developer comes in, if you can just say, here is the standard like training machine that we are using, they can just start using it if you have defined this stuff in code, or at least defined it in a particular way. Right? And this is quite often overlooked as well. Data scientists will have their machine which has all of their libraries in it, and they do their training and they produce their model file. But if somebody new comes in, they can't really do that work because they're not on the same machine. And these are problems that we've seen in computer science for years and years as well. So having a definition of what these machines look like and what these dependencies look like is really important too. Automation is a big one as well. And this again depends on that life cycle we were talking about. Automation is one of those things where you speak to somebody who's been doing DevOps for a little while and they're like, yeah, that's where we build a pipeline that does everything for us, which is great, but that's not the end goal, right? The end goal is to be able to make changes and make sure they're okay and push them into production if they are, and experiment and be able to change things and have that cycle, that life cycle, all right? So automation for things that you do more than once is really handy and can be really handy whether you're writing code and deploying it to production or whether you're running experiments, for example. So if you wanted to do, if you wanted to train your model using a bunch of different things and you have very similar data that comes in each time, redoing those same tasks every single time might be something that you can automate. There's a really cool XKCD comic. There's always an XKCD comic, which is basically just says, over 5 years, here's how much time you have to spend before you start saving time again. So just to summarize, let's say you do a task weekly, and it saves you a minute each time. Doing this automation will save you a minute. You can spend 4 hours on that thing and get your time back, right? And so this is like a funny kind of joke, right? But this is serious. Like, if you can automate something and you do it every single day, and by automating it you save an hour, you can spend 10 months on this project, like, to automate that thing, and you will make your money, you'll make your time back in 5 years, right? So if you do the same thing more than once, maybe consider whether you can automate it. If you can automate everything that happens in a repeated process, then it's going to save you a lot of time, right? So this can apply not just to computer science and things like that. This can apply to data science projects too. We talk about in DevOps as well things like continuous integration, continuous deployment, continuous testing. So continuous integration is really just where you take your code and everybody else's code and you push it together and you make sure it still compiles and it passes all your tests and things like that. But you do that on a continuous basis. In other words, you're not writing code that sits completely isolated from everybody else's code, and then one day in 3 months' time, you try to merge it and realize that stuff doesn't work anymore, right? This is directly a little less applicable to data science, I think. But you do have potentially lots of data scientists working on the same problem, right? So having a way of continuously running your training or running your tests and doing that kind of stuff in a pipeline that doesn't require these data scientists to sit there and talk to each other about, oh, hey, I'm doing this now. Is that going to affect what you're doing? Having this continuous process where this stuff happens automatically can be valuable. It comes into effect even more when you talk about continuous testing. So in other words, when you're building this stuff up, are you monitoring the scoring that comes out of these trained models? Are you cutting this stuff off early if it's not working, right? Are you running tests against not just the training and the produced models, but are you running tests that test for like edge cases? If you trained a model and there's like a log that comes out somewhere in the middle of all of these calculations in your model that you've created, and you've only ever given it positive values, are you testing the edge case where somebody inputs a negative value? Right? You can test your code. It's Python, it's R, it's whatever you want to use. You can still test that, and that means writing that code in a way that is testable. Running those tests every single time you make a change to your model training can be really handy as well, just to make sure you haven't inexplicably introduced a bug that you didn't expect. Right? So continuous testing can apply as well. And of course, we get to the operationalization of it, which is continuous delivery, where we've created this model, or we've created this way of creating a model. We get a model out the other end, and then what do we do with that model? Docker seems to be what people have landed on lately, especially for operationalizing this stuff. So you create a model, you wrap it in a basic API, and deploy that as a Docker container. That has a lot of really big advantages. One is that that container is an artifact, or that image is an artifact which represents not just the model, the predictive model that you've created, but it's also this portable thing that you can move to somewhere else to either try it out on a new application, try it out on a new hardware, run it on a drone. I don't know if you've seen like those DJI drones that can run Docker containers. That's amazing, right? If you have some kind of vision analysis that you've created and you can run that Docker container on a drone, and because you've built this pipeline, you can maybe tweak and improve that vision model that you've created, run it through that pipeline, it creates a Docker container out the other end, and you can push it up to the drone. That's fantastic. You can also use continuous delivery techniques to do things like A/B test predictive models. So you could have a cluster of Docker images which just contain this self-contained model, this predictive model that you have. And then you point some of your application instances to the new version of it, and you check the scores, you monitor it, you continuously monitor what's happening in production and work out whether it's performing better or whether it's not. Which kind of leads to production monitoring. Can you actually look at what a model is doing and determine whether it is successful or not, whether it's improving or whether it's getting stale, potentially. So you could deploy a predictive model that your application uses to tell people whether, or to tell people what movie predictions, or what movies they may like based on the things that they've watched, you know, the Netflix style of thing, right? Can you look at what people are doing with the output of that model to tell you whether that model is successful or not? And this could be a hard problem, right? One way I can think of to do that is you actually A/B test your different models and you look at funnels, like are people clicking on their recommendations more or less with this new model that we've deployed? If it's more, then maybe we roll that out a little bit further. So these kind of techniques can be applied to data science projects as well. One thing I'll mention as well is that these two things, so data science project where you create a predictive model at the other end, or something that's going to tell you some information that you want to direct your business, and the software that might potentially use this model, these two parallel activities are often done in a really disconnected way. And I don't think that's necessarily a problem, right? The cadence is going to be totally different. Your developers might be updating your Netflix-style website 20 times a day. You're not going to rebuild a model 20 times a day to do that stuff. It might be 3 or 4 times a week. But where it does come together is where the application needs to work out what model to use. So there's a lot of techniques you can use. And simply having an artifact of the current model that the data scientists have produced and having that as part of your build pipeline with your application or part of your deployment pipeline with your application can be really valuable. You say, I'm deploying a new version of the application. What is the current predictive model that my data scientists have said is the best one right now? Pull that down, deploy it with the application. Right? So this kind of stuff can be done. Now, as for tooling, like I said, it's not fantastic at the moment. There's nothing great that does this work right now, I don't think. Everything that I've seen has gaps. That may change soon. We are doing some things, and there's a conference next week in Orlando, I think. So stay tuned for stuff. But this idea of having this process that can be tracked, experiments tracked, models produced, operationalized, and used as part of your pipelines is something that we are definitely focusing on. So I've kind of just talked a lot, right, at this point. I want to summarize kind of the highlights of what I think you should be looking at if you're trying to get some DevOps processes into your data science projects. So number one, actually there's 2 pages of this. So my summary is less of a summary. It has more words than the titles that I had. But here's kind of the outcome of it. So keep everything in source control, and it doesn't have to be source control. You don't need to teach your data scientists to use Git. Like, I'm a developer, I can barely use Git, right? I know 4 commands, and if it doesn't work after those 4 commands, I go to Stack Overflow or ohshitgit.com, which is fantastic, by the way, or I speak to this guy. So you need to be able to keep everything in source control so you can see what you've done, and you need to be able to allow for experimentation. So doing things like requiring your data scientists to create a new branch every time they do an experiment, if they're explicitly having to go to Git and create a new branch and do that kind of stuff, they're not going to do it. I barely do that stuff, right? Most of my Git process is doing a whole lot of changes and then committing them and going, oh no, I'm on master. All right, let's create a new branch and put the changes in that one and then submit a pull request, right? So, and I'm a developer, right? Telling your data scientist to create a new branch every time you do an experiment, it's not really going to work, right? But you need to allow for that because that's part of the process. Using canonical data sources is really important. So that example I gave of pulling everything down from the real database, tweaking it yourself, and then having your own little database that you train on as a data scientist, not appropriate, right? You need some way of saying this is the real data that we are training on. And it may not be the production database. It may be an extract of the production database that you do on a regular basis. It may be streamed data that's filtered so you're not getting any personally identifiable information. But you need to be able to say, that is the data that my models are trained on. That is the data that we are using as for the creation of our predictive models, all right? So Don't let the data scientist have their own special little database that they're not really sure how they got, or a dump of something they did 3 months ago, right? A canonical data source to say this is what we use is really important, especially when you build up pipelines. Don't be afraid to refactor how that data is stored too. It may not be able to change what's in production, but maybe you can add a stream, some kind of streaming to it, so you can store it in your own way. Standardizing your environments in code and defining those in code make it really easy not just to kick off new training sessions or new experiments, but also for new data scientists who come in. They have all of the stuff that you need immediately to do their work really effectively. And this is something we do in computer science a lot. Automate wisely, and don't just assume that everything, because we automate everything in in computer science, that you're going to want to automate everything in data science. If you do it more than once, definitely look at it. But if it's a once-off report, you don't have to enforce this stuff every time, I don't think. And then pipelines can be really useful for repeatability and being able to explain what you did to get to a particular stage. And if you're saving artifacts at the end of each of those, you can say, well, we did this, here's what we ran through, this was the build process or the training process, the scoring, and here's our model at the other end. And then we abandoned that because we didn't think it was good enough, right? But that process means that you can repeat it over and over again, this pipeline, and explain what you did each time. Deploying portable models is some advice from Paige Bailey, who works for Microsoft. She is really, really strongly of the opinion that you shouldn't be writing a model for that specific purpose. Write the model, the predictive model, and then wrap it in something which makes it portable, right? So a portable model is not an Excel spreadsheet which has the answers to the 12 questions that your boss asked you. It's a model that you can query to give you an answer whenever you feel like it. And you might want to query it from a web application right now, but in 3 months, maybe you want to open that up to a phone application that somebody is using as well, right? So having a portable model is easy to do and definitely worthwhile. And then testing your models continuously and monitoring what's happening in production so that they don't get stale, and having a data refresh strategy and a training refresh strategy is important as well. One other thing that we talk about a lot in DevOps that I haven't mentioned here is this concept of shift left, right? So the idea with shift left is if you can discover a problem earlier in your life cycle or earlier on when you're doing the work, it is far cheaper to fix it then than it is when it's in production, right? So if there is a problem with this process, this data science process, and you can fix that problem earlier by, for example, standardizing your environment and meaning that everybody is using exactly the same machines to train their models, that is an easier problem to fix right up front than trying to work out why this person's model looks totally different than this person's model when they should have done the same thing, right? So keeping this in the back of your mind is really handy as well, shifting left. A couple of resources as well. It's a bit of inception, but that is a link to the slides that I'm showing right now. If you wanted to have a look at some of those as well. They're not great slides, they're me drawing, but it might remind you of some of the stuff that I've looked at. And that team data science process document is up there as well. I would also highly encourage you to keep an eye on Ignite next week in Orlando for data science process and AI stuff as well. That's all I'm allowed to say on that. So I think I'm a little bit early, so I have plenty of time for questions, I think. But other than that, thank you very much. So questions, because I have questions. Yes.
I was just curious what your view on notebooks, Jupyter notebooks, and how that fits into DevOps.
So I think everybody can hear it because there's a mic, but I'll just repeat it anyway because that's habit. My view on Jupyter notebooks and how that fits into DevOps. So when I first saw Jupyter notebooks, I was like, this thing's amazing. So for those who aren't familiar with it, it's basically, is it always Python? Yeah, no? Nope. Oh, sorry, okay. So you can do C# in Jupyter notebooks? All right, I know what I'm doing tomorrow. But basically the idea is you have the code that you're doing that's doing the work, and then you have Markdown, or you have some kind of description of what you're doing like above it. And so the best examples of Jupyter Notebooks might be, okay, I'm going to get this data from this particular database. It contains this information, and we're just going to analyze it to see what it looks like in a scatter plot, just to give an idea of whatever. And then you have the code that does it, and then the output that comes out of that, and you can see what it does. And so you're basically walking through the process you did as an exploration of that data, or as a transformation of that data and things like that. So the first time I saw Jupyter Notebooks, I'm like, this is amazing. It's like documentation alongside the code and then alongside the output. And it's fantastic. All you need to do is do all your work in those Jupyter Notebooks and then version them in source control, and then everybody can just get going. The difficulty I've seen since is that it's really hard to version control that, because I believe it's like a massive chunk of JSON under the covers or something, something like that. Yeah. That's like complaint number one, but I have a few more.
So actually you can version control notebooks. Notebooks are, Python notebooks would be, Jupyter notebooks would be a text file. The problem is each of those cells you're talking about that you're stepping through, it's kind of wrapped in some kind of weird markup thing.
Right, okay.
However, if you look at Databricks is actually a product that does it really, really well. And you can hook up your Git to run your notebooks and version control. So whoever works, if your team works on those notebooks, they can do even diff that doesn't bring you to this ugly notation. And another benefit, especially of Databricks, is that you can take a notebook and run it, as a batch without looking all this, and treat it literally like a batch file for your cluster.
Okay, thanks. Is that Databricks or Azure Databricks?
It's the same.
Same thing. Okay. So when I've looked at the source control stuff for Databricks, I've seen it use GitHub or Bitbucket. Is that right? As long as it's Git is what I've been told. Okay, so yeah, that can work with the source control stuff. Often Jupyter Notebooks are just somebody's running stuff on their machine, but yes, I definitely take the point. There's other things like if you can run the cells out of order, and you can work with these things, and it just doesn't give you what you expect, and it's a bit unpredictable and things like that. The other bigger one for me though is operationalizing that. So can you put your Jupyter Notebook in production? And you probably can, but should you? Is it testable as well? Like if you do these 5 steps to get your data in a particular format, how do you test that step 3 is a function that does what you're supposed to do? And so from a computer science perspective or software development perspective, at second glance, it just didn't seem quite as nice. I mean, the Python is what you care about. And yes, absolutely use Jupyter Notebooks to do your experimentation and your analysis and your all of that kind of stuff. That's great. But when it comes to something that you need to put in a pipeline to get a model out the other end on a repeated basis, I would really prefer to see the Python extracted into like actual Python modules and things like that you can call externally. And you can do that stuff with Python, with Jupyter Notebooks as well, can't you? Some of it. This sounds like a long discussion.
Yeah, sorry, not a question, but at the last JupyterCon, there was actually a talk about why I hate notebooks, which was really, really good. And there was a huge Twitter storm afterwards. I'd recommend looking that up and looking at the comments that followed.
So that talk actually is or the slide deck, somebody sent me that, and that was where I was like, before I saw that slide deck, I'm like, yeah, Jupyter Notebooks are amazing. And then I saw the slide deck and I'm like, yeah, that's probably right. I mean, ultimately, if you're using Python, for example, or if you're using Scala, you said was one of the other options. Pretty much anything. Oh, nice. Okay, yeah, so you can attach a kernel to your notebooks and run whatever code is there. So yeah, so you have the description and you have the code. The code is what matters when you're actually building the thing. Description's definitely useful. And you could keep your notebooks in source control or inside other stuff so people can see what you've done. But when it comes to actually building a pipeline to repeat this stuff and do it over and over again, then I think having the code in real code files that can be called externally in a kind of nice, repeatable way and can be tested individually can be really, really valuable and maybe would be a nicer way to go. in my opinion. I'm coming at it from a developer opinion as well, remember.
So one of the things you mentioned there was testing a cell. If you've got a notebook and one of those cells is transforming 1 billion rows of data sets, how do you test something like that?
Well, the first thing is if you have that cell, you could extract what's in that cell into a function or something like that you can isolate. Sometimes the way that it's written, though, it doesn't lend itself to testability. Being able to extract that stuff to say, here is your input and give me the output, if that is an encapsulated function, much like we do in software engineering, you can run tests against that encapsulated function. Create your test data set, which maybe is 30 rows, and then push the data into it and pull it out the other end. Maybe try putting in some rows that are partly empty or have negative values or just have completely incorrect data to make sure the thing doesn't explode at the other end. So having that stuff that's in a cell or that series of functions where you care about what the output is given the input, if that can be extracted into its own function or module or something that you can isolate and test very much like you would test a class or a function or something in your application. That's one way of doing it, but that does require you to not use Jupyter Notebooks as far as I can tell. Yeah.
I think notebooks are really good for exploring the data and trying it out and the rest of it. The sort of testing you mentioned there, maybe when you've produced a model and you want to put stuff in and get specific types of results back, maybe something like that's a bit more testable.
Yeah.
But there's no reason why you can't be checking in a Jupyter notebook or a Databricks notebook.
Yeah, true.
Versioning it and be able to go backwards and forwards on versions.
Yes.
To see what you did.
Yeah, and you're right. Like if that is an important part of the process, which led to the outcome that you have, to the thing that's in production now, having that in source control is great. Similarly, having documents in some kind of version controlled system, like your requirements documents and stuff like that, absolutely you should be version controlling that. And again, it might not be Git. It might be I don't want to say SharePoint, but it might be SharePoint, for example. So same kind of thing. Having that thing that's important to your project, having that in a version controlled system, can be really, really important. But when it comes to the actual application that it builds that model and you need to test and you need to run through a pipeline, I don't know if notebooks is the right solution for it. That said, like right at the start, when I said these are the things you need to care about, languages and tools, if your data scientists use Jupyter Notebooks, then don't tell them not to use Jupyter Notebooks. Just tell them in order to enable this pipeline, this way of doing stuff, let's sit down together and let's work out a way of turning what you've got in the notebook into something that we can repeat later on, like extracting those functions, extracting those modules, and doing that kind of work. Like part of DevOps is not one person or one team telling another team how to do stuff. It's sitting down together and actually working through these solutions together. So maybe the last 5 minutes of my discussion has been like, no, don't use the tools that you want to use. Sorry, I want to back away from that. Use the tools you want to use, but sit down and try and work out better ways of having that life cycle behave nicely for everybody. Yeah. Cool. Yes.
So, do you have any recommendation for any tool or idea how we can keep track of different versions of data?
Different versions of data. That's like the really hard thing, frankly. So I've heard two arguments for this. One is you absolutely need to keep versions of data. That means you need to have some kind of strategy. Either you snapshot your data on a regular basis so that you can say, at this particular date, this was the version of the data that we have. And that might be feasible for your organization, but if you're just out of curiosity, the Azure DevOps product, which is the other thing that I talk about a lot, they collect telemetry on how people are using the product, and they collect, I think it's something like about 1 petabyte a day of data, just as the telemetry. Are you going to snapshot that every day? No, you're really not going to do that. So that's just not feasible. So saying we need a versioned history of all of the data it's a tricky problem to solve. I don't know of any tools that do that really nicely at the moment. What you could do though is snapshot, or snapshot the diffs, I suppose, is one way of doing it. So if you had your data, and then every time somebody did a write, you wrote the fact that there was a write at that particular point, then you're not snapshotting, you're just keeping a log of all the changes that occurred. And I think, Lace, you had a project that did something really, really similar lately, right? Yeah. Sorry. Thanks.
Hi, I'm Lace. I'm actually part of Microsoft and the commercial software engineering. So we had a similar project which required basically repeatability of your pipeline, and your data was constantly changing. So we essentially identified different types of data. One was the small data sets where you can literally snapshot when you need it. And there were the incremental data sets where all the changes to the data sets were effectively inserts or writes, in which case, and they were sequential writes, in which case you don't need to snapshot because you just know until which point in time did you run your model, and you can reproduce your data set. And the third and trickiest data set was where you have updates and deletes. And that's what Damian was saying around actually just recording the change. So you have a change log over time. So you don't delete records, you soft delete them. You don't really update records, you just soft update them. So effectively every row is immutable. And you're just inserting your soft deletes and updates. And what we did is we created a view of which basically translates the most up-to-date view of your data set. So as a person querying the data, I don't have to worry about, select, update, where is the soft and what's the current view of the data. So that was probably the trickiest part. So we call them different delta types within the data set. So there's certainly different ways without actually snapshotting a petabyte of data, but the third type is probably the trickiest one.
Yep.
Yeah.
The other argument I've heard, and this is obviously only appropriate for some scenarios, is don't even worry about it. And then that's quite often in scenarios where you use that data to create a predictive model, and then you have that model as an artifact you always store. How you got that model, you use the data at the time, and you might retrain it using up-to-date data, but you're never going to need to retrain that thing based on old data. So you don't need to worry about it, right? Obviously, only some scenarios that's valid for, but you may not even want to keep old data. You may want to train the model and keep the old model, but don't worry about keeping the old data. So that's also doing nothing is also a solution. It's an option, yeah. Cool. I think we are towards the end of the time. My Twitter handle as well, by the way, if you are one of the data scientists and you're like, everything this guy said is crap, right? Then I definitely want to hear from you as well, because as I said, I'm coming at this not from a data science perspective, from a development perspective, but I want to make this stuff that we're doing work for both sides. So really like talking about this stuff, so hit me up, especially on Twitter, or email if you want, damovisa@microsoft.com will get to me too. Awesome. Thank you very much.